Good day to all. Today we can discuss the topic about progression. What is progression? Progression is the sequence of operation. But in mathematics, the progression is called as a sequence of numbers. Why the mechanical engineer are studied about the progression and the sequence of numbers? What is the importance? Let's see. The first, the sequence of numbers can be arranged like 1, comma 3, comma 5, comma 7. Here, the numbers are having the uniform interval, which means in between 1 and 3 there is 2. 3 and 5 there is 2. So the uniform interval, and also that interval has the incremental 2 factors. So plus 2 increments available. Likewise, in right hand side you see 8, 6, 4 comma 2 likewise available. The difference between 8 and 6 is minus 2. Similarly, the difference between 4 and 6 is minus 2. So the sequence of numbers are arranged with negative manner. So these kind of number sequence are available with progression. Not only this, other than this, the geometrical progression is also available. What is that? Yes, let's see. Before that, what is the definition for arithmetic progression? Let's see. Arithmetic progression is a sequence of numbers in order in which the difference between any two consecutive numbers is a constant value. Likewise, 1 comma 3 comma 5, in three numbers 1 3 have the interval as 2. Similarly, 3 and 5 have the six intervals of 2. So the uniform interval available, so the constant value is 2. So it is known as arithmetic progression. Then what is geometrical progression? Geometrical progression, here you see the numbers are arranged as like 2 comma 6 comma 18 comma 54 likewise arranged. Is there any uniform interval available? The 6 and 2 has the difference of 4. Similarly, the 18 and the 6 has the interval of 12. Likewise, the intervals are varies. So geometrical progression is differs from arithmetic progression. So, what is arithmetic or geometric progression? A geometric progression or a geometric sequence is a sequence in which each term is varied by another by a common ratio. Here, what is common ratio? Here you see 6 by 2 is equal to 3. Similarly, 18 by 6 is equal to 3. So, the first term 2, the second term is 6. 6 divided by 2 is equal to 3. Similarly, 18 divided by 6 is equal to 3. Likewise, the common ratio available with this number. Likewise, here geometrical progression, it also has its own decremental value. Here you see that 24 is the initial number, 12 is the consecutive number, and 6 is the another consecutive number. Here, what is the ratio? Here you see 24, 12, 6 likewise available, the same as previous. 12 divided by 24 is equal to 1 by 2. The 6 by 12 is equal to 1 by 2. Likewise, the common ratio available. This kind of progression is called as geometrical progression. And then, what is the use of these kind of progressions? Generally, the progressions are used as a arrangement of numbers. In that arithmetic progression we discuss, and also geometrical progression is widely used in gearbox design. Here gearbox design has different gears, n1 n2. N1 means speed of gear. So we can arrange the different gears as a sequence manner, n1 n2 n3. How the engineers are designed the gearbox with respect to geometrical progression we see. Okay, so generally the gearbox spindle speeds are arranged in a geometrical progression. In gearbox, the speeds, the gear 1 has the speed of n1, the gear 2 has the speed of n2. So these gears are arranged with the geometrical progression. First, before going into geometrical progression, we should aware about what is meant by arithmetic progression. How do we calculate arithmetic progression calculations? Already we are aware about arithmetic progression definition. Now we move to arithmetic progression incremental problem. Here you see why I told incremental 2, 4, 6, 8 available. Here the plus 2 available every intervals. 2 plus 4 is equal to 4. 4 plus 2 is equal to 6. 6 plus 2 is equal to 8. Likewise, we have the uniform interval, so which is called as incremental arithmetic progression. Here, for arithmetic progression, we have the formulas like L is equal to A plus N minus 1 into D, which is the formula for the arithmetic progression. Here, the terms are available L, A, N, D. What is the meaning for that? Yes, here the A available. The A means first term considered. According to our sequence, here 2, 4, 6, 8 available. Here what is the first term? 2 is the first term. And then A. What is the A? A is the first term. 2 is the first term. After that L. L is the last term considered. Here what is the last term? Here 2, 4, 6, 8 available. Here 8 is the last term. So L is equal to 8. After that N is equal to number of terms. Here you see how many numbers of terms available. 2, 4, 6, 8. 4 terms are available. So the N number of terms are 4. Okay, after that the another term D, unknown term, is D. What is D? D is the common difference. According to our intervals, the 2, 4, 6, 8 available, the interval is 4 minus 2 is equal to 2. Similarly 6 minus 4 is equal to 2. Similarly 8 minus 6 is equal to 2. So the common difference D is equal to 2. These are all the terms available with the available incremental sequence of number as a progression. Here the formula is equal, I wrote like L is equal to A plus N minus 1 into D. Here we can check the formula. So here we know the value L, A, N, D. Okay, here from the value of A, N, D, I identify the last number, which is L. So how do I calculate? Yes, we can see L is equal, I substitute the value of A into 2 it into the term A. So L is equal to 2 plus N is equal to 4 and then minus 1 and the D is equal to 2. Likewise, I substitute the value. From this I can get the equation like this. After that I simplify this. I can get L is equal to 2 plus 4 minus 1 is equal to 3. So 3 cross 2 I can write. Okay. After that I simplify further. L is equal to 2 plus 6 because 3 cross 2 is equal to 6. So L is equal to 2 plus 6 and then L is equal to 8. Here you check according to our sequence or progression. We have 2, 4, 6, 8. L is the last term considered. According to our sequence, we get the same value 8. So which is the formula for identify the last number or last term available with our sequence. Similarly, if I consider the decremental means 24, 22, 20, 18. Likewise, decremental available. Here also the interval between 24 and 22 is minus 2. And then 22 and 20 is another minus 2. And 20 at 18 I got minus 2. So the uniform interval occurs, but the uniform interval has decremental factor of minus 2. Here also we can utilize the same formula, which is L is equal to A plus N minus 1 into D. Here L I should identify. Here the last term is 18. Shall we get check? A is equal to, what is we have first term 24. A is equal to 24 I substituted, and N. N means number of terms. How many numbers available? 1, 2, 3 and 4. So N is equal to 4. And the difference already I determined minus 2. So here A for 24, N for 4 and D for minus 2 I substituted, and I got the equation as like L is equal to 24 plus 4 minus 1 into minus 2. And I simplify this means I get L is equal to 24 plus 3 cross minus 2. How do I get the 3? Got the 3? Yes, 4 minus 1 is equal to 3. So 3 into minus 2. So finally I can simplify this equation also. So L is equal to 24 plus 3 into minus 2 is the minus 6. So L is equal to 24 minus 6. So according to this, I got 24 minus 6 is equal to 18. So L is equal to 18. According to the available sequence, the last term available with this arithmetic progression is 18. I got 18. So the what is the sum of 2, 4, 6, 8? There is any formula? Yes, available. If I have the sequence, yes, I can get the or find the sum of the available sequence also. So here for the identifying the sum of sequence, the formula is S is equal to A plus L divided by 2 into N. Already we know about A, L and N. So A is equal to, according to this problem, A is equal to 2. A is equal to 2 and L is equal to 8 and N is equal to 4. So I substitute the value A for 2, L for 8 and N for 4. So if I simplify, this means 8 plus 2 is equal to 10. So I can get S is equal to 10 by 2 into 4. If I simplify further, I can get 10 by 2 as 5. So 5 into 4 is equal to 20. So the sum of 2, 4, 6, 8 as 20. Now you can cross check with the manually. Here 2 plus 4 is equal to 6, 6 plus 6 is equal to 12, 12 plus 8 is equal to 20. If we can utilize this formula for large number also or complicated number also, we can easily get the sum value for the progressions, which is known as arithmetic progression. Next, we can move to geometric progression. In gearbox design, we generally utilize the geometric progression. So we should aware about what is geometric progression, how do we calculate the values. Here, the geometric progression, I first consider about incremental numbers, which are 2, 6, 18, 54 and etc. Here, as usual, we are having four numbers 2, 6, 18, 54, and the first term is 2 and the last term is 54. The intervals, I can't get the uniform interval, it varies, but I do identify any other method. What is the method? Here the L, the last term can be identified through L is equal to A into R power n minus 1. The sum of all the four terms can be identified through the formula of S is equal to RL minus A divided by R minus 1. Here already we are about what is A. A is the first term. According to this problem, A is equal to 2 and L last term is 54. So 54 and then N. How many numbers available? 2, 6, 18, 54. There are 4 numbers. So N is equal to 4 and here there are no uniform intervals available. So we should identify the ratio. What is ratio? The successive numbers. Here the 6, I consider the 6 as the next number. The successive number is 2. So likewise I divide 6 divided by 2, I can get the 3, which is called as progression. Here another sequence, in this sequence I can pick the 18. 18 divided by 6, we can get 3. And also I consider the another number is 54. 54 divided by 18, which is also 3. So we are getting the common ratio for the sequence. So which is a ratio of progression R is equal to 3 according to this problem. Here also we can solve the last number, last term, which is 54, which can be identified through A into R power n minus 1. Here what is L? 54 already available. Can we get or not? Shall we check? Okay, here A2 I substituted here, or the ratio 6 by 2, which is 3 power n minus 1. What is n? Here 4 terms are available, so that 4 minus 1. So if I divide 6 by 2, I can get 3. So 2 into 3, 4 minus 1, I can get 3. So 2 into 3 power 3 I can get from the solving of this equation. After that, 3 power 3 is 27. So 2 into 27 is equal to 54. Yeah, here you see the 54 is the last term from the progression. So I can get the 54 from the available progression. So now we can sum up all the things, we can get the value from formula is S equal to RL minus A divided by R minus 1, which is the formula Here already I aware about R ratio is equal to 3 and L last term is 54 and A the initial number is 2 and then R ratio 3. Likewise I substituted, I can get 3 into 54 is equal to 162. So 162 minus 2 divided by 2 I can get. Further I simplify this, I can get 160 divided by 2. So at last I got the 80. So sum of the progression, available progression is 80. If you want, you can cross check. 2 plus 6 is equal to 8. 8 plus 18 is equal to 26. 26 plus 54 is equal to 80. Likewise, we can get the progression. Here we see about, we saw about incremental numbers. Why not? We can see about decremental numbers also. Here I can present 24, 12, 6 as like a decremental manner. So decremental progression also we can identify through geometrical progression. Then how? A, here the first term is 24 and L last term is 6 and total numbers available 24, 12, 6. Likewise 3 numbers I got from this progression. So 3. And next I should identify the ratio of progression. Here you see what is the last number 12, the second number is 12 and successive number is 24. So 12 divided by 24 is equal to 1 by 2 I got, okay, which is the ratio. After that I can check the formula, the last number for L is equal to A into R power n minus 1. Here L last term I know 6, I want to check 6 is equal to 24 into ratio R is equal to 1 by 2 I got in previous step. So I substituted here 1 by 2 power n minus 1. N is the 3 number, 3 minus 1. Here 24 into 1 by 2, 3 minus 1 is equal to 2. So I can simplify this. After that further I can move to simplify 24 into 1 by 4. If I square the 1 by 2 I can get 1 by 4. After that if I simplify 24 into 1 by 4, I cross 4 and 24, I can get 6, which is the last term. 6 is the last term from the available progression. Then the formula S is equal to RL minus A divided by R minus 1. You may aware what for this formula we can identify the sum of available progression. So here R ratio I can identify through the previous step, which is 1 by 2 and L is equal to 6. The last term is 6 minus the A is the first term, so 24. So I substitute all the corresponding value with respect to the equation. I can get this form. Furthermore, I simplify this 1 by 2 into 6 is equal to 3. 3 minus 24 divided by, if I subtract 1 by 2 minus 1 means I can get minus 1 by 2. So here 3 minus 24 is equal to minus 21 divided by minus 1 by 2 I can get. I cancel the negative, the denominator and the denominator. So I can get the thing. Here I can shift the place of 1 by 2 into top position. I can multiply the 21 into 2, I can get 42, which is the sum. We can check 24 plus 6 is 30 plus 12 is 42. May I get the correct answer or not? Yes, this is the procedure. This geometrical progression we can utilize for identify the gear ratios or gear sequences in gearbox design, which is the mathematics available in behind of a gearbox design. Every mechanical engineer we should aware about this geometrical progression and the progression also. Thank you.